Doing basically just going over the quiz. Because there are a few mistakes that were fairly common, and we want to review for that. I do have the other quizzes for you too, and I'll hand those back too before the end of the hour. So remind me if it's getting close, and I haven't done that yet, so that I can get those back to you as well. So you have both the quizzes to study from tonight, and then return those just as normal, and we take our test tomorrow. So you get the normal routine here. The test really isn't much longer than this quiz. And this quiz is really like pretty much a pretest because you're doing almost everything here that you would do on the test. Identify the conic section and find its eccentricity. And actually, we're going to go ahead and graph it too just for practice here for the sake of the review. So we get the practice of actually graphing as well. So let's take a look at this first one. It was 16x squared minus 4y squared. I'm going to go ahead and regroup right away. I get how to remember how to get 16x squared plus 64x minus 4y squared plus 16y. And is going to equal 16 on the other side. All right. Most people are fine with factoring this one. We got a 16 out of here. We get x squared plus 4x and then plus 4 to complete the square. But we're not actually adding 4 in there. We're adding 16 times 4, so we add 64. Now, here's where the mistake was made by a lot of people as we dropped a negative sign. Factor out the negative 4, we're left with y squared minus 4y plus 4. So we did not add 16 to both sides, we actually subtracted. Negative 4 times 4 is what we added in here to complete the square. So I have to subtract 16 over here, so that gives us 64. There's where the mistake was made by most people. You lost that negative sign. That was our most common error. Okay? Because from this point, most people were okay with the idea of dividing through by whatever you had. 16 over 60, that gives me x plus 2 squared over 4 minus y minus 2 squared over 16 equals 1. Okay. The eccentricity. Okay, this is A. A is 4. A squared is 4, excuse me. And B squared is 16. C squared is A squared plus B squared, which would be 20. So C is the square root of 20, which is 2 root 5. And A is 2. So C over A is 2 root 5 over 2, or just root 5. So there's my eccentricity, square root of 5. If I were to graph this, and this was not part of the problem, but it's a good review for the test. Go ahead and graph this hyperbola. The center of the hyperbola is at negative 2, 2. So negative 2 up 2, there's the center. Ooh, I'm not oriented well. Just see if we can fix that quick.
So in an ellipse, the a squared is the bigger number, and then in a hyperbola, the a squared is always the positive one?
This is the first one, yeah.
Okay.
The first one should always be positive. All right, so there's my centers at negative 2, 2. My major axis is 2 units each way from that, so my vertices are there at 0, 2, and negative 4, 2. Those are my vertices. That's my transverse axis because it's horizontal with the x. My conjugate axis is vertical and 4 units each way from the center. So 1, 2, 4, 2, 4. Okay, so there's my box. All right. My diagonals then get drawn in. My asymptotes do. And it's a left-right opener. So my vertices here are at 0, 2 and negative 4, 2. My foci, focal points, if you don't like the word foci, you can always say focal points, are square root of 5, or sorry, 2 root 5 distant from the center. So this would be out here somewhere, and that's, well, 2 root 5 is what? Root 5 is about 2.2, and 2 times that would be 4.4 approximately. So, actually probably a little further. So 1, 2, 3, 4, probably about more like there is my focal point. And that would be negative 2 plus 2 root 5, 2. So 1, 2 about here, that would be negative 2 minus 2 root 5, 2. Those would be my focal points. The equations of the asymptotes, remember that's y minus k, or y minus 2, equals plus or minus b over a. B is 4, 2 over a is 2, so 4 over 2, or just 2, x plus 2. Same y minus 2 we have here, the same x plus 2 we have here. It's just that the b over a, plus or minus b over a, those are the equations of the asymptotes. That's all right there in that equation. And that's pretty much everything we need to know about that hyperbola. Like I said, the biggest mistake is when factoring out the negative 4, forgetting to change this from positive 16 to a negative 4. And also when we're adding to both sides, remember it's a minus 16, not a plus 16 on both sides. Okay? We got to be especially careful with hyperbolas because of that darn negative sign. But that's what's going on. Number 2, identify the conic and graph it. So this is another good problem for us. Most people got that this is an ellipse. In fact, I don't think anyone missed that. If I divide by 9, I get x minus 1 squared over 9 plus y plus 2 squared over 1 equals 1. That's how we convert it into our standard form. So that wasn't that much difficulty. I mean, you had to divide by 9. You didn't have to complete the square or anything there. That was pretty easy. Then we had to graph it. And as long as you got a general graph of it, I was okay. But, I mean, some of you folks, honestly, you can't just go and I'm done. All right? That doesn't cut it. You've got to at least label something. All right? You got to label something for me. And honestly, graphing conics, you should always label all the major features of it. I wasn't real picky about it, but on the test I will be. I expect almost everything to be labeled. So the center of this is at 1, negative 2. The major axis is horizontal. It's a little bit tight. Major axis is horizontal and 3 units each way. So that's -2, -2. And 4, -2. The minor axis is 1 unit long and vertical, so 1, -3, and 1, -1. There's my ellipse. Just to finish this out and to complete everything we could possibly do with this, let's find the foci. C squared equals A squared minus B squared here. So that's 9 minus 1, or C is the square root of 8, which is 2√2. So 2√2 we said just a minute ago, or 2√2, yeah, 1.4, 2.8. So 1, 2, 2.8. So you have a focal point there and one foot there. So this is 1 plus 2√2, -2. And this is at 1 minus 2√2, -2. The eccentricity is C over A, which is 2√2 over 3. It doesn't really simplify at all. One thing people were forgetting is that this is A squared, not A. So they'd put like 2√2 over 9. But that pretty much tells us everything we need to know about that ellipse. That's pretty much everything. That's above and beyond what you need to do on this quiz, but maybe not on the test. We'd expect everything. Number 3, write the equation of the hyperbola with eccentricity and this. Boys, start with a picture. It comes to something like this. So we're given the foci are at 0, 9 and 0, -1. Okay, those are the foci, which means the center must be smack dab in the middle of those. So 9 plus -1 is 8, so that gives me 4. There's the center of my hyperbola. So I already know, and it's going to be, obviously it's going to be opening up down if those are the foci, right? Foci have to be inside the curve. That vertical axis, that's opening up down. So it's going to be y minus 4 squared over something minus x minus 0 squared over something equals 1. A lot of people mix that up. A lot of people put the x first. This is up and down opening because the focal points are vertical like this. Those have to be inside the curve. It has to be the y first. Eccentricity is 5/3. Is C over A. So that means A is 3. So A squared is 9. Okay, so A is 3. C is 5, which makes sense. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Fits perfectly. And we know since it's a hyperbola that C squared is A squared plus B squared. So C squared would be 25 equals 9 plus B squared. So B squared has to equal 16. Here's my equation. And if I were to graph that, again, we go 1, 2, 3, 4. 1, 2, 3, 4. So my graph, if I had to do that, okay, we draw on our diagonals. There's my hyperbola. This point is 0, 7. This point is 0, 1. We've got the foci already in there. Remember, a common mistake people make when they're graphing hyperbolas is to put the vertex through to mix up the vertex and the focal point. They make it go through the focal point instead of coming down all the way to the box. That's actually the vertex. But like I said, the biggest single mistake people made here was they swapped these two. I saw it very commonly. But it's very clearly with the focal points on a vertical axis like that, that has to be a y squared first. It's opening up down. Okay. And I know that's backwards from parabolas. Parabola, if it's the y squared, it opens up right left. They're different. Okay, so. All right. Solving algebraically. A lot of people struggled with this one, which kind of surprised me. It's just a parabola and a line. So if we start with the sketch, okay, oops. Start with the sketch. Y equals 3x minus 1. Well, that couldn't be easier. Slope of 3, intercept of negative 1, of 3. Sometimes hard to see this. 3 over 1. Okay. Right. So we get a line, something like that. The parabolas are always a little bit tricky. The vertex here is at 2, negative 3. 2, negative 3 is my vertex. It opens up because x minus 2 squared equals 2y minus 3. So it's probably doing something kind of like this. Looks like I got a point of intersection somewhere around here, and my other one's going to be way up high somewhere. But they will intersect at some point. So we look at our equations. X minus 2 squared equals 2y plus 3. But y equals 3x minus 1. Oops. So it seems pretty obvious that we're going to take this 3x minus 1 and put it in for that y. That's my substitution. So x minus 2 squared equals 2 times 3x minus 1 plus 3. Foiling this out, this is x squared minus 4x plus 4 gives me 2 times 3x is 6x, gives me plus 2, so that's going to be plus 4. Subtracting 4 from both sides, subtracting 6x from both sides, I get x squared minus 10x equals 0. So I factor that, that's x times x minus 10 equals 0, so x equals 0 or x equals 10. If x equals 0, we substitute into the original equation, and y equals 3 times 0 minus 1, which is negative 1, so that gives me a point 0, negative 1. That looks about right. If x equals 10, y equals 30 minus 1, which is 29. So 10, 29 is my other point of intersection, which makes sense. Where did we pour in a difficulty here? Not foiling this out, right? This is x squared plus 4, or x squared minus 4. Not remembering to foil out binomials that are being squared has been an issue, ongoing. Or just simple arithmetic mistakes in here as well. So, 2 points of intersection there. Most people did 5 just fine. I'm not going to spend a lot of time on that. There were no real problems with number 5. Most people did just fine with that. Circle, radius 3, center at the origin, shade inside. Hyperbola, Vertex is at 1, 1 for both sides of the hyperbola. Now, the one thing I did run into with the hyperbola a little bit, and you do need to be a little careful about this when you're drawing your hyperbola, is I had a lot of people draw their hyperbola out like this. That's not a hyperbola. That's two intersecting lines. Hyperbola really does, it curves. Sometimes that's why a pencil is always a good idea. Okay? And it doesn't just stay here at 1, it curves to the axis. So be careful as you're drawing that. It's not just 2 straight lines, not really, I had a couple people who just drew 2 straight lines. I took off a point because that's just like, no. It's a curve. And it approaches the axis, not the line x equals 1 or y equals 1. So be careful. Number 6. A lot of difficulty with number 6. X squared plus y squared equals 34. And x minus 3 squared over 2 plus y, or minus y squared over 9 equals 1. I got to find the intersection of those two. We're going to have to do some substitution. It's going to be easiest to substitute in y squared for y squared. Okay? That's going to be easiest substitution. So y squared is 34 minus x squared. So substituting that into this equation, I get x minus 3 squared over 2 minus 34 minus x squared over 9. And notice I do not square that. I'm substituting for y squared, not for y. So I don't need to square 34 minus x squared, because it's already y squared. Equals 1. My choice would be first to get rid of the fractions. Some people decide to FOIL out first, but I choose to get rid of the fractions. Now, what you can't do is multiply this by 9 over 9 and this by 2 over 2 and do nothing over here, which I saw a lot of. Let's multiply the whole thing through by the common denominator of 18. Everything gets multiplied by 18. Then reduce it. That's 9 times x minus 3 squared minus 2 times 34 minus x squared equals 18. Foiling this out, this is 9 times x squared minus 6x plus 9 minus 2 times 34 minus x squared. Whoops. Equals 18. Distributing, I get 9x squared minus 54x plus 81 minus 68 plus 2x squared equals 18. Combining terms, that gives me 11x squared minus 54x plus 81 minus 68 is 13. Minus 18 is minus 5 equals 0. I think that's right. Okay. Yep. All right, and now we have to factor that to find our solutions for x, or use a quadratic formula. Factoring isn't going to work so good, probably. So we're probably just going to apply the quadratic formula, which, by the way, in case you're wondering, is written on the boards, both places. So 54 plus or minus the square root of 54 squared, actually negative 54 squared, minus 4 times 11 times negative 5 all over 2 times 11. So my calculator, when I do that, This winds up being a perfect square and being 56. So 54 plus or minus 56 over 22. 54 plus 56 is 110 over 22, which is 5. If I do minus, I get negative 2 over 22, which is negative 1/11. Those are the values for x. Once I've got those values for x, I have to find the y's, and y squared equals 34 minus x squared. So y squared equals 34 minus 5 squared. So y squared equals 34 minus 25, or 9. So y is plus or minus 3. So that gives me the point 5(3) and 5 negative 3. Or y squared equals 34 minus 1/11 squared. So y squared equals 34 minus 1 over 121. And that will decimalize. Okay? So 33 and 120 1/21. Yeah. And take the square root of that and do a plus minus on that too. We wind up with 1/11 and approximately 5.83 and negative 5.83 when we decimalize that. Okay? But basically just a lot of algebra difficulty there for people. I mean, a lot of algebra difficulty. This is a little more complicated. At least if you got the substitution correctly, I tried to give you some of the points. I mean, it was a 4-point problem, so almost everyone, if you did something, I gave you a point. If you did something pretty close to correct, I gave you a couple points. But a lot of people lost it right about here. They got a substitution. A lot of people did 34 minus x squared squared. Remember, you're substituting actually for y squared, which is what we have here. So I don't need to square this and get an x to the 4th situation in this particular case. So that was a little more, that was a more difficult problem for a lot of people. Number 7 was D as in David. Then we went BCB on the pack page. A lot of people for number 8 answered C. Let me just kind of go over this real quick for you, because that was a pretty common mistake. And then we'll return your other quizzes to you. But the equation was x squared minus 6y squared plus 36y equals 60. So if I want to get that in a form I can work with, this is x squared minus 6, y squared minus 6y plus 36 equals, I did negative 6 plus 30. Can I put that down right? Oh, plus 9. What am I doing? Plus 36. Sorry, there's my mistake. Working too fast. Plus 9. So that's minus 36 from each side, so that gives me a 24. So that's x squared minus 6, y minus 3 squared equals 24. So if I divide by 24, that's x squared over 24 minus y minus 3 squared over 4 equals 1. So C equals a squared, c squared equals a squared plus b squared. So 24 plus 4 is 28. So c equals 2 root 7. What am I? Not like 54. Oh, wait a minute. I say something's not right here. 54. 6, isn't it?
Yeah.
6, and this becomes a 1. Okay, so there's the 7. There's my 7. So c squared equals 7. So c equals plus or minus square root of 7. And the center is at 0, negative 3. It's opening horizontally, so we go on the horizontal axis. So root 7, negative 3, and negative root 7, negative 3 are my vertices, are my foci. Sorry. Wasn't planning on running through that one, so I had to run through it in my head again this morning. Rest of my head. So, anyway, that pretty much covers it. That covers, and really that's covering almost everything on the test. We didn't do a lot of stuff with directrix here right now. But are you guys okay with the directrix of a parabola and stuff like that? Just directrix and focus and stuff like that. This covers most of it, really. I will hand back your other quizzes. We've got them right here. Don't forget it's homeroom day today. So,
Maybe one more.